Hello everyone, how you all doing? This video is the next video in the series of three-dimensional geometry of 11th class, and in this video we are going to discuss the easiest concept of all times, that is the distance formula. Now if you don't know about the concept of distance formula between 2 points, then you must watch my videos of the chapter coordinate geometry of 10th class that are already made, and the playlist is also available, so you can go and have a look at the videos of distance formula that are under the title of coordinate geometry chapter, right? So you'll be able to know this video in a much better way. So now, previously, if here is a point that is, and the coordinates are x1 y1, and here is a point that is b, the coordinates are x2 and y2, what we were doing till now, we were finding the distance between these 2 points by using a very easy formula. That was, the distance was equal to root x2 minus x1 whole square plus y2 minus y1 whole square. That's it. The formula was still here only. But now we are dealing with the distance formula in 3 dimensions. So of course we have to include the third dimension, that is the third axis, the third coordinate, that is z coordinate as well. So now the coordinates of A will become x1, y1 and z1, and the coordinate of B will be x2, y2 and z2. So we can very easily generalize the formula from 2 dimensions to 3 dimensions, because your D will be simply equal to root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So yeah, you can see clearly that the term which is involving z-axis is simply added, and in this way you have gotten the distance formula to find the distance between 2 points in 3 dimensions, right? So let's just implement the formula on some of the sums and you will see how easy things work. This is our first example of exercise 12.2, and in this we have to find the distance between P and Q. The coordinates are already given, so we will represent the distance as PQ, and let me write the formula once again for your understanding. X2 minus x1 square plus y2 minus y1 square plus z2 minus z1 whole square. So now here this is x1 y1 z1, x2 y2 z2, so you can simply decode that, I guess. Now just fill in the values. What is our x2? That is minus 4. What is our x1? That is 1. So minus 4 minus 1 whole square plus what is y2? That is 1 minus of minus 3 square plus what is our z2? That is 2, then minus 4 whole square. So what will you get? Minus 5 square plus 4 square plus minus 2 square. In turn you get 25 plus 16 plus 4. So 16 4, that is 20, 40, and that is root 45. So we can find the root by using prime factorization. We can simplify that. So 3 ones are 3 and 5s are 15, 5 then 1. So of course there is a pair, that is 3, so 3 will be taken outside the root and 5 will be inside. So 3 under root 5 units is our distance between 2 points P and Q. And this way you can simply apply the formula, simply write the formula and just fill in the things, fill in the coordinates which are already given in the statement, and you will get your answer in seconds. This is our preceding example, and in this we have to show that the points P, Q and R are collinear. So co means same and linear means line. So the points which lie on the same line are known as collinear. I guess you know this thing very well. So points P, Q, R are collinear, then they must be lying on the same line. So how we can prove that these points are collinear? Just simply we have to prove that PQ plus QR is equals to PR. Only then it will be proven that these are lying on the same line, right? So what will we find? We'll find PQ, we'll find QR, and we'll find PR by using our very favorite distance formula, right? So just write the distance formula. You have coordinates, so I'll directly fill those coordinates, right? Because it's easy for you guys, so we shouldn't waste time, right? PQ, that is x2 minus x1, that is 1 plus 2 square, then plus 2 minus 3, that is 2 minus 3 square, then 3 minus 5 plus 3 minus 5 square, right? So just take out the values. What are the values? That 3 square 9, 2 minus 3 minus 1, so minus 1 square, that is 1, so 9 plus 1 minus 2 square, that is 4, so 9 plus 1 plus 4, that is root 14. Just don't mind that I am writing this much tight, because I want that it should finish only in the single line, so that's why. So 9 plus 1 plus 4, that is root 14. So in a similar way we'll find the value of QR, right? So this is Q, this is R. What we will do, 7 minus 1 square plus 0 minus 2 square plus minus 1 minus 3 square, because here it's 3, right? So what you will get, 7 minus 1 6, 6 square, that is 36, 0 minus 2 minus 2 minus 2 square, that is 4, minus 1 minus 3 minus 4 square, 16, 16 plus 4, that is 20, 20 plus 30 50, and that is a root 56. Then we have to find PR. So P and R, the Q point will be omitted, right? So 7 minus minus 2, that is 7 plus 2 whole square, plus 0 minus 3 whole square, plus minus 1 minus 5 whole square, right, is equals to root 7 plus 2 9, 9 square, that is 81, 0 minus 3 minus 3 minus 3 square, 9, minus 1 minus 5 minus 6 square, that is 36. So when you will add that is 9 10 16, that is 6, then here it's, you will get 2, then 1, so you will get root 126. So now here is PQ is root 14, and then the next thing is root 56, and PR is root 126. Now how we will get to know that if this plus this is equals to this? So you have to simplify roots a bit. So take the prime factors of 56. So let's see what we get, right? 56, so 2 2s are 4, 2 8s are 16, then 14, then 2 7s are, then 7 1s are. So it means this is a pair, so root 14 will be here only, and 56 we can write that 2 root 14, right? So the answer should be 3 root 14. So let's see if we'll get 3 root 14 after taking the prime factors of 126. I guess we'll surely get, right? Now 126, that is 2 6s are 12, 2 3s are 6, then 3 2s are 6, and 3 1s are 3, 3 7s are 21, 7 1s are 7. So yeah, 3 is a pair, and 7 and 2 are not forming a pair, so 3 root 14 will be our answer. So in this way we have concluded that PQ plus QR is equals to PR, which means these 3 points are collinear. So this is how the concept of collinearity works, right? So let's move ahead. This is the next example. In this 3 points are given, and we have to verify that are these points forming a right angle triangle or not. So firstly, form a triangle basically. So if it is a right angle triangle, so we are just assuming it to be a right angle triangle. So ABC are our 3 vertices, and what's A? That is 3 6 9. Then what's B? That is 10 20 and 30. Then what's our C? That is 25 minus 41, then 5. So if these are forming a right angle triangle, if this is a right angle triangle, then of course it must hold the Pythagoras theorem true. So we have to prove that AB square is equals to AC square plus BC square, right? So, or simply you can take any of the 2 coordinates, that is A here and B here and C here, or B AC. So by any means you can prove that it is forming a right angle triangle or not. Firstly, we'll find AB, and you must remember that we have square root on the right hand side of our distance formula, so we can just convert it to the square on the left hand side. So we can write AB square is equals to 10 minus 3 square plus 20 minus 6 square plus 30 minus 9 square, right? What will you get? 10 minus 3 7 square, that is 49. 20 minus x, that is 14. 14s are 196. 30 minus 9 21. 21s are 441, and after adding these you get 686. So one side is concluded, and AB square we have got. So now BC square. What is BC square? That is, if you write 25 minus 10, that will also work. If you write 10 minus 25, that will also work. So it will be 25 minus 10 square plus minus 41 minus 20 square plus 5 minus 30 square. So what's it? 25 minus 10, that is 15. 15s are 225. Minus 41 minus 20, that is minus 61, and you can calculate the minus 61 square. I am writing directly, that is 3721, and 5 minus 30, that is minus 25. So square of minus 25 is 625. After adding these you will get 4571. So AB square is done, BC square is done. Now the turn of AC square. You will get 25 minus 3 whole square plus minus 41 minus 6 whole square plus 5 minus 9 whole square. So that is 25 minus 3, that is 22. The square will be 484. Minus 41 minus 6, that is minus 47, and the square of minus 47 will be 2209. 5 minus 9 minus 4, the square will be 16, and after solving you will get 2709. So now simply add any of the two sides, any of the two squares of sides, and just see if it is coming equal to the next side or not. So we'll add AB square and BC square, right? Or AC square and BC square, it's totally up to you, AC and BC. So just add 2709 and 4571, and what is our AB? That is 686. So you can clearly see that after adding this you will get some 4-digit number. This is 3 digits, so in no universe this is going to be equal to each other. So that's why this triangle is not a right angled triangle. We can easily conclude it. Now we have just applied the distance formula plus the very well known Pythagoras theorem, because it was a right angle triangle, so that's why Pythagoras theorem held true, and that's why we use that, and we have concluded that this is not a right angled triangle. So yeah, it was easy. Here is the concluding example of this exercise. In this we have to find the equation of set of points P such that this one condition is given, that PA square plus PB square is equals to 2A square, and A and B are also given. So firstly we have to find the equation. So there must be X, Y and Z in the equation, and of course there will be K because it's already given. So we have basically to find an equation, not any point. So to apply this condition we must be having point P. So we'll consider point P as X, Y and Z. So what's the condition? PA square, PB square. We'll firstly find PA square. Just as in the previous example, there will be no root on the left hand side. So PA square, that is if P is this and A is this, so you will get X minus 3 whole square plus Y minus 4 whole square plus Z minus 5 whole square, correct? In the same way you can find PB. So what is PB? That is X plus 1, because minus minus plus whole square, then Y minus 3 whole square plus Z plus 7 whole square, because minus minus again plus, so Z plus 7 whole square. So this is what you have got. Now in the condition PA square and PB square are getting added, so you will add these. So PA square plus PB square, when they will add you will get 2K square. So I am just directly writing, and then you are going to add these equations. It means x minus 3 square plus y minus 4 square plus z minus 5 square, then plus x plus 1 square plus y minus 3 square, and plus z plus 7 square. Now you have to expand each and every bracket. I know it's gonna be very lengthy one, but yeah, you have to find equation, the simplified equation. So just expand the brackets. X square plus 9 minus 6x, then second one y square plus 16 minus 8y, then the third one z square plus 25 minus 10z, then fourth one x square plus 1 plus 2x, then fifth y square plus 9 minus 6y, then last one z square plus 49 plus 14z. So 2k square is a constant thing, right? So we will be just solving the constant terms, and we'll just take it to the left hand side. So here it is 9, and here it is 16. So 25, then 35, 41 and 9, that is 50. Then 59 plus 1, that is 60. 60 and 40, 100, 109. So 109, here it is of plus sign, and on this side it will be of minus of 109. So we have solved the constant terms. Now the turn of square terms and other. X square and x square, that are forming 2x square, y square plus y square, that are forming 2y square, and z square plus z square, that are forming 2z square. Minus 6x plus 2x, minus of 4x, minus 8y minus 6y, minus of 14y, and 14z minus 10z, that is plus of 4z. So this is our required equation. Yeah, it was supposed to be lengthy, yeah, but I have skipped one or two steps because I know you will understand it very very clearly. Alright, so this was the last example of this exercise, and we have formed our required equation. So while solving any of the sum, if you find any query, any doubt, any problem, you can DM me. My Instagram ID is given in the description, and I'll be waiting for your queries. Now please subscribe my YouTube channel, and don't forget to press the subscribe button before you leave my channel, and stay tuned to witness these kind of more informative videos, right? Thanks for watching. All the very very best for your exams, and see you in the next video.